Wow. Thank you very much, Michael. Thanks, everybody. So welcome to this evening, everybody. It will be a blast, I'm sure. And also welcome to all you who are on the live stream. It was fully booked immediately when Michael added this announcement. So I think there is more people looking at the live stream, and we will pick up questions from there, from the chat, of course. So I'm running Factor 10 since the beginning, and legend. And I thought it's super egoistic of me and my colleagues to keep that to ourselves. So we wanted to share that. So we wanted to let more people hear some funny things from Erik. So I'm super happy to have Erik on stage. So big hands for Erik Meijer.
That you're muted, even like here. It's like, all right. So yeah, I would like to tell you a little bit today about my journey in the world of AI, and it will be a little bit of history, a little bit of future looking, and the title is like Hinton's Nightmares, My Dream. It's a little bit of a joke. Hinton, the godfather of AI, or how he's called, has been warning a lot about the dangers of AI. This is from a recent interview. I think this is from a few days ago. AI might escape by writing its own code and take over the world. Hopefully, after this talk, you will think, no, that's really, really far out. But that doesn't mean that AI is not useful. And so let me give you my own journey. So I'm in the 80s, that's when I went to college. There was something called the Japanese fifth generation project. So they were building new hardware and new software based on Prolog. I don't know if people here remember the language Prolog, logic programming. Everything was using logic, Lisp, and people were doing thinking that mathematics would be the way to do AI. And so I wanted to do my PhD in AI, but quickly I realized that this is all too difficult. I was trying to do natural language processing, and oh my goodness, that was so hard. And I decided, I won't swear here, but now I should insert a swear word. This is too hard. I'm going to do artificial languages. So that's when I went into programming languages. And I did a lot of programming language work, a lot of fun. But then around 2016, 2017, I noticed that the people that stuck with AI were having more fun than the people that were doing programming languages. I don't know, to see the 21st version of C++ or the 14th version of C# or whatever. It gets boring after a while. And these folks were they could do magical things with neural nets. Suddenly they were capable of actually doing stuff. And so I switched from programming languages to AI. I gave away my whole team, and I started a new group to do software engineering, or AI for software engineering, so AI for developer productivity. And then now, of course, 2022, 2023, is that the generative AI is the big hype. But if you think that here's some old guy telling you about the 80s, most of you were not even born in the 80s. But if we go even further back, in 1956, a group of researchers thought we can spend the summer thinking about AI, and then it's solved. So famous last words. So this wasn't solved at all. But I do think that now I think we made some good progress. And I really feel that after these large language models became real, we're definitely in a phase change. And these things can now do actually useful things. But I don't think that they are intelligent. But maybe your opinions differ. So let's look at the problem that when I was in the 80s, when I was looking at AI, was like a big, really difficult topic, a non-monotonic logic. Now that sounds already quite impressive, right? Logic, non-monotonic. What does that mean? Well, normally when you reason, when you get more facts, it means that you know more, but it should never invalidate things that you concluded before. Now, is that true? Well, let's give a counterexample. So if you know that Tweety is a bird, we all know that birds can fly. So we can conclude that Tweety can fly. And everybody goes, yeah, of course, Tweety is a bird. Come on, dude, it can fly. But then you say, oh, but by the way, it was a penguin. And now suddenly it's, oh, yeah, no, it cannot fly. So we cannot conclude that all birds can fly. And so this is like non-monotonic logic. So it's you know more facts, and suddenly you have to retract previous conclusions. And as I said, this is a big thing. People build all kind of mathematical theories about this, and build expert systems that could reason with non-monotonic logic. That was something I tried to do for my PhD before I gave up. So now let's ask ChatGPT the same question. Tweety is a bird. Can it fly? You see, this thing is super smart. It kind of starts already. Yeah, it kind of can fly. It kind of cannot fly. So who knows? It's hatching its bets. And then I say, oh, but Tweety is a penguin. And I say, oh, sorry. I'm so sorry, Erik. It couldn't fly. So sorry for my allergies. There's the Swedish grass is different than the Dutch, and the American. But anyway, so Tweety cannot fly because it's a penguin. So now let's ask, but why did you say that it could fly before? And now it kind of explains, right? Oh, I kind of assume that it's a bird, so it can fly. So actually, this thing is pretty smart if you look at it from this perspective, because this is very high-level reasoning. So pretty good. All right, so now let's take one step up the abstraction ladder. And why do I think that AI is useful for, and we're all here for developers in particular? And the reason is that I think it allows for a virtuous cycle. And let's show a virtuous cycle that has really driven our industry. And that's the virtuous cycle between software and hardware. So we built, and of course, what's the chicken, what's the egg? But let's say we start with hardware. Now, because we have hardware, we can run software. And because we have software, we can build tools to create better hardware. And then we have better hardware, so we can build more powerful software, and then we can build more powerful hardware. And that's what maybe drives Moore's law. It's this this virtuous cycle where hardware and software amplify each other and just goes quicker and quicker. This flywheel goes quicker and quicker. And this will continue for a long time. Now let's look at the vicious cycle, which is a cycle where things slow each other down. And this is, unfortunately, for a lot of us, reality. This is the vicious cycle between business and software. So software enables business, but as the business grows, the software things become much more complicated. So the software becomes much more complicated, but then it enables the business, and so our work gets more and more complicated. And then we try things like Scrum and Agile and so on to deal with this. And so that's really a hack. I think it's a hack. So what we do is we try to build this little thing here on the side, another, like what is a virtuous cycle, where we build tools, we come up with processes, and so we think that, oh, better software will enable better tools will enable better software, so this flywheel then powers this flywheel. But as you all know, I'm not a big fan of Agile, I'm not a big fan of tools, I just want to write freaking code. Right? I don't want to have all this overhead, I don't want people to tell me I have to stand up and like play poker. Like I want to play poker, but not poker like, you know, when I write code. So can we get rid of this here, right? Can we get rid of software engineering? That's my goal. And turn this into a virtuous cycle. And this is the insight that I had. Because if we replace software by AI, now suddenly we do get a virtuous cycle. Because AI enables business. Now, when the business grows, it generates more data. And that data was what really complicated the software. But now we can use that data to train the AI, which enables the business, generates more data, which we can use to train the AI. So suddenly, we have created a virtuous cycle. What's even better is that we've eliminated this. So the future of AI, the promise of that is that there will be no more Agile, there will be no more stand-ups, there will be no more planning poker, and we'll all be free. And we will be free to get, like, hack again, right? To do what we really want. So you have to thank me for this, right? Because I don't think that anybody here kind of enjoys that kind of part of their work. All right, so as I said, like I started a team that used like all the like, you know, internal like if you think about like what is that kind of data, right, that gets generated? Well, it's things like when you have source control, you see like, you know, code that appears, you see like, you know, if there's a fix, you see code with a bug and then the code without the bugs. So that can be used as training data. You can see people making comments when they have a diff. You see comments. So based on all that data, you can build tools, AI tools, that will help you writing code. And we wrote a paper about this, AI and software engineering. And in that paper, we talked about 3 AI models that we built. One is code search using natural language. Second one is code recommendations, and the third one is automatic bug fixing. So let's go to the automatic bug fixing. As I said, you have code with bugs, then somebody fixes the code, then you have code without bugs. Now you have a pair of code with bugs, code without bugs. That's like a training example. And so if you have enough of these, then hopefully you can train a model that can then create bugs. Interestingly, we also use this the other way around. We created a model that can create bugs. Now you think, Erik, why would it be useful to have a model that creates bugs? Well, it's actually super useful because I'm sure everybody here does TDD, writes all their tests. But how do you test your tests? Well, you do that by feeding it programs that are buggy. But how do you get programs that are buggy? Well, you let the model generate programs that are buggy from programs that are correct. And the nice thing is that this now allows you to stress test your tests. So this is great. And there's also a paper, if you search for that, where we explain that. And the nice thing about using models to create buggy programs is that as humans, we don't write really like nasty buggy programs because we're like, you know, we're maybe not vicious enough. But these models, they will like write the nastiest buggy programs, and it's great. So yeah, I can really recommend that. Like use a model to write buggy code. All right, so now what happened in the meantime? November 2022, ChatGPT came out, and that changed everything. Suddenly, all the work that we did with the team, hard work where we had like people with PhDs in computer science and machine learning, suddenly all that we worked on for so many years could be done by this model. And not only could it be done like, one task, it could do all the tasks where we had all these different models. That was quite, well, at first, like a disappointment, right? Like, all your work gets, you have seen these videos of monks building these mandalas with sand, so they work on that for years, and then they go, it felt like that, right? It felt like all my work was kind of just wiped away in one go. But it also is refreshing, because now you can kind of start from scratch. And that's what I did. I think I really like these models. They're much more powerful. But let's look back a little bit and see why this was wiped out, right? So let's give some concrete examples. So first thing, code search using natural language. And the idea is that, like, if you're a good coder, you're lazy, right? You don't want to write code yourself. You want to first find, did anybody else wrote this code before? But of course, like, if you don't know what names people use or how to find that code, so you don't know the name of the method or the name of the class. So what you want to do is you want to give some English description of the code, and then you want to be able to find that. And so that's why you want to search with natural language. We used code embeddings there, just like now people use text embeddings. But we thought, code has different structure than text, so it needs to respect the fact that code is ASTs with variable bindings. It was super complicated, but it worked. And so we were really proud. But now let's see what ChatGPT can do out of the box, right? Without having like a whole army of PhDs that built these special models. So write a circular buffer in Hack. Hack is the language that's got Facebook's variation or Meta's variation of PHP. And it's not very widely used, right? It's like used inside Facebook or Meta, but not out there. So you would expect maybe like ChatGPT doesn't know about it, but it says sure. And here it gives you it doesn't even point you to the code. It kind of actually writes it for you, right? Which is even better, because if you could, what we could do is we could do code search, but it would find existing code, but this thing will generate code for you, which is even better than search, right? Because it can find things that are not even there. That's magic. But anyway, so works great. So our work was wiped out. Second thing, code recommendations. This is like guidelines. How do you safely use code? What are conventions? Maybe you have to always use exception handling. You have to do null checks. There's lint rules, probably in your companies. This is something that you do. And so what you want is if you have a piece of code, before you put it out for code review, you want the AI to do the code review for you, right? To tell you, hey, Erik, you're a really lousy programmer. You should put some error handling around this. So let's look at here. So this is actually an example from the paper. And again, we were really proud that our custom model could do this. So it's how do I safely use this API? And guess what? It does exactly what you want to do. It tells you exactly you have to put some try catch around it, but it also puts in all the comments. This is way better, even though this is a simple example, but that was the best our previous model could do. And now you look at this, were we really proud that it could do something this trivial? But yes, again, all the sand away from the table. Third one, automatic bug fixing. This is great, right? It's of course, this doesn't matter for you because you all write correct code from the start, but I write a lot of bugs, and I want the machine to fix my bugs. I want to be sloppy. I like to just get, like, type something and then have the machine fix it for me. And so that was the idea. The other thing that you can also use is you can call it bug fixing, but maybe say that you have a new version of an API and now you want to refactor all your code. In some sense, that's also automatic bug fixing, right? Where you want to do automatic big refactoring. So a bug doesn't really have to be a bug, but it's anything that can improve your code. And here you just tell it, like, hey, fix some potential bugs in this code, and then it explains and fixes all the bugs. This was also an example from the paper, and it just does it. And it was even better because it also explains what it does. Now, what is interesting is if I give it this code with a bug, so this is the code it fixed here. This was Java. If I now ask it to translate the Java code to Kotlin, it will translate it to Kotlin. And then it says, by the way, Erik, this Java code has a bug, so I fixed it for you as well. And when I generated this thing here, I got that from a piece of Python code, and it did the same to me. So I asked, translate this Python code to Java, and then it fixed the bug for me. So I had to ask the model, translate this from Python to Java, but leave the bugs in there. So it fixes bugs even without asking. So fantastic. So all the 3 things we were so proud of are now trivial. This one model, where we had different models, that one model could do everything. So the way I describe it is it really felt that we were digging a tunnel with pickaxes and shovels, and then somebody shows up with dynamite and heavy equipment and says, kiddo, get out of the way, leave this to the professionals. Now, but this is good, right? Because as this kind of quote from Hinton in the beginning, it's this AI will write its own code. That's my dream. That's what we were working for, right? We want the AI to write the code for us because it's hard work. It's difficult. We make mistakes. So if we can let machines write code for us, I'm super happy. And in some sense, this is what we've been doing since the dawn of computer science. What is a compiler? It is letting a machine write code for us, because we don't write assembly code. We want to write code at a higher level of abstraction. Except a compiler is kind of like a dumb AI, right? There's no AI there. It's just a deterministic translation. But if we say something in English and some program translates it to executable code, that's like a compiler, right? So Hinton says we should be afraid of compilers. That sounds quite different than that we have to be afraid of AI. But again, for me, it's just a compiler. It takes a high-level representation and turns it into executable code. And if this thing is smart and maybe it's non-deterministic, I don't care. It does the work. Now, you might say, Erik, if these machines are writing our code, our brains will kind of atrophy. We will end up like in the movie, Wall-E. But this is the same argument that people that don't use the metric system use against the metric system. If we take on the metric system, our kids will become stupid because now it's too easy. You just shift the commas around. No, they have to do the math to exercise their brains. And obviously, from how I say this, I don't believe in that. I think it's great to make things easy. And so I don't believe in this enfeeblement. I think, for me, in some sense, time is the most precious resource that we have, right? You cannot save time, you cannot buy time. So that's the only thing that's really of value for humans. And so if we waste our time on something that a machine can do, that is kind of like a bad thing, right? That is inhumane. Of course, if we choose to do so, that's fine. Like the same thing. Like if I lift a heavy load, we're using machines for that. But I like to do weightlifting, but that's fine. But I should not be forced to do like that hard labor. And the same thing here. Like if I want to write code or assembly code for fun, that's great. But if a machine can do it, like nobody should do it as a human. So I think it's actually great. And I don't believe in this enfeeblement stuff. I think humans should, like, we should do everything to save our precious time such that we can use that for human activities and not waste it on things that machines can do. That's maybe my 2 cents of philosophy here. That said, there's also maybe a darker side if you're a pessimist, because I think a lot of us, like developers and so on, we work out really proud, right? We study hard, maybe you didn't go to college, but you worked hard on your craft, and now suddenly this is the first thing that gets taken over by AI, the first thing that machines can do. If you have a plumber, although like we sometimes compare developers with plumbers, right? We're kind of just gluing stuff together. But the real plumbers, that is much harder to automate away. So I think this is a little bit unexpected. So I think we as a group, we thought we would be safe, but we are in some sense the first ones that are affected. But here, let's automate ourselves away and have fun doing it, right? Like if we are the last generation of actual developers, let's have some fun, right? Like don't be pessimistic. It's great fun. It's like automate yourself away. Like think of this. We are in all history, we are the generation that can do this. They couldn't do it before the large language models. Once it's done, they cannot do it anymore. So there's one chance of a lifetime. This is literally a chance of a lifetime to automate yourselves away. So let's do it and let's have some fun. All right, so how do we do that? Well, let's look at some hierarchy of AI tools for development. So there's things like Copilot, and then Meta is something called Code Compose. That is kind of like the way I would say it's like AI-powered typing, and which is nice. But I think if you're already writing code, then it's not really going to help you, right? You already know what you're doing. The model gives you autocomplete suggestions. It's okay, it's convenient, but it's not like a transformational change. It's not going to make you 10x better or 10x faster because you kind of already knew what you were doing. Then, people saw this, I think now there's Copilot X where you can chat with things. There's ChatGPT, and that's a little bit more like AI-powered search where you can search things, but it still doesn't do things for you. Right? And now people are thinking about, if you read things like Baby AGI, AutoGPT, this is where the AI is actually doing actions. So it's kind of exploring. And I think these AI-powered workflows, that is when we really automate ourselves away. Because I kept talking about how fun coding is, and look at your day job, coding is just tiny part of the whole workflow, right? And so if we automate coding away, then we still don't have time to do things that we really enjoy because there's all this other overhead. So we should really think about automating the whole software lifecycle. But that means that the AI also has to do more larger workflows. So it has to do code reviews. It has to do debugging. It has to get all these other things. And so let's talk a little bit about that aspect. And here is I'm going to program this, give you a little bit of an example here of how I would automate my workflow. When I write code, now I've got like sounding more sophisticated than I really am. I write some tests before I write any code. Then I write some code until the tests pass, and then I clean up my code. In practice, I never write any tests. I never clean up my code, but hey, like, okay, this is the idealized Erik. So let's kind of like encode this thing as a kind of like workflow. So we have an agent, or let me call this an agent now, because these things might or might not have AI in them. So we have an agent that can run tests. We have an agent that can fix bugs. And we have an agent that can refactor code. And the loop here is like, until all tests pass, you can like, run the tests. If a test fails, you fix the bugs. Once all the tests pass, we know that our code is correct, right? And of course, we do this kind of like, we generate nasty programs to stress our tests. But then once we're done, we kind of like clean up our code. So simple workflow, I guess most of you kind of like use it like this. As I said, like these things don't have to be AIs. So let's look at the code fixer agent. What I like, and I think this is, and of course I might be wrong, but I think this is the future, that you just write regular code. So on the outside, it just looks like a class with normal methods, but on the inside, the implementation might use AI. So this is a bug fixing thing, and what it does is it just like you give it some buggy code, you give it all the test errors, and it gives you some kind of like fixed code. And in this case, it will call say ChatGPT or GPT-4 or Llama or whatever model you want. But on the outside, this just looks like a regular function, right? Because this you could even maybe use Mechanical Turk here or whatever. So it doesn't really matter. So I really think it's important that these things don't show on the outside. It's like the fact that they're using AI is just an implementation detail, right? But it just looks like a normal class. And then, of course, now, instead of writing code, we have to tell the model to like prompts, that's the new code. And I don't know, probably all of you have kind of like played with these large language models. And now I'm getting pessimistic. What we did is we replaced something that we kind of understand, code, with something that we have no clue about, so a prompt. And what you do is like, what you often see in these prompts, you're begging the model, right? Avoid adding this, as the code will be tested using unit test. So we're trying, and you see people writing things in all caps, like it's like, some kind of like spam email. And like, it's like you have to enclose code in triple quotes. And then, of course, it doesn't put things in triple quotes. And then you put in your prompts, you must put it in triple quotes. It's really kind of like hard. And then once you have your prompt done, the next day, it doesn't work anymore, because maybe the underlying model was changed. So it's really, really hard. And how do you know that this is the shortest prompt, the most optimal prompt? We don't know. So I think we've traded off something that we kind of knew, to something that we don't know at all. Is this an advancement? I don't know. But it's fun, right? It looks like magic. All right, so let's move on here. Let's show the program. So here's the little program that I'm trying, and it took me quite a while actually to find an example that the model, in this case I used GPT-4, that the model couldn't fix in one cycle. Right, so but that wouldn't be fun, right? Like if it could fix all the test errors and the syntax errors in one go. So it was a little bit of a tweak. But here's the code. It checks if the parentheses are properly nested. And then, as I said, since I never write tests, I just had the model write the test. So I said, here's the function, write me some tests. I think they look pretty good, right? And it saves me from counting, is this really kind of correct or is it not correct? But yeah, so you highlight the model, write the test. And now we run it. We run this test agent. And this test agent it just runs the test, right? So there's no AI in there, except that the tests were generated by an AI. And what you see here is that the first round, it will find all the syntax errors. Okay, now we give the error messages and the code to the model, and we say, fix it. And then it says, oh, I fixed it. I replaced the input with this. I moved this statement outside the block and added a moving brace. I don't know about all of you, but first of all, I don't like source control because I don't think it solves any problem, real problem. I mean, like, who here can go back 3 months in their source, and then it still, like, compiles, right? So maybe you can get your source code to 3 months back, but then, of course, all your dependencies have changed, especially if you're doing JavaScript or some front-end work, and you can never get it to compile again or run again, right? So why do you do source control? I don't know. And then you have to write these freaking commit messages. Like, why, who invented this? Like now you have to come up with something, like, what do I want to say about this code? I never know. I always, like, I don't know. But here, look at this thing. It just explains what it did. It doesn't complain. It's very clear. Great, fantastic. So, like, why would we ever write commit messages ourselves anymore? And this thing can do it much better. All right. So now it fixes the syntax errors. We run it again, and now the code compiles, but one of the tests fails. And so we give this code to the bug fix AI again. And it explains again, like, exactly what it does. Again, I don't have to write a commit message. I can just now copy and paste this and commit the code. Of course, I should really test it anymore. But again, now I run it again, and it passes all the tests. So we know, right? It passes all the tests, the code is correct. And now, but it looks kind of ugly, right? It does ugly, so now we can fix it. And then it even kind of, like, tells you how it refactored it. And so I love this, right? Because all the things that I don't like about programming, explaining what I did, doing all this, it is much better than us to do it. And it has infinite patience. And maybe we let another bot read this, so we as humans can always ignore this stuff. This is just noise. I am only interested in the code. And here it kind of looks nice. So, yep, this is like the workflow. And as I said, it's really like this loop, and it has these 3 black boxes. These could be either contain AI or might not contain AI. Now, of course, you say, Erik, but this is not really intelligent, right? Because it is a fixed control flow, and it's not, like, you know, the AI didn't come up with this flow. And so that's the next step, where you want the model to come up with, to find the gap, like this algorithm, right? You don't want to do it yourself. And for that, and I'm going to, given the time, I'm going to go a little bit quicker through this. There's many techniques to do this. One of the techniques is called React, and that's not the React that you know from, like, front-end development. But I would advise all of you, maybe forget about the old React and read up on the new React, because the new React, that's the future, and the old React is the past. Because the new React will write the old React for you, okay? So let me show you a little bit about the new React. And so what it does is you ask the model to, you give the AI a task. So in this case, create a photo of a cute dog on a skateboard and come up with a caption for the image. And then you ask the model to come up with a step towards the goal to solve this thing. And then when it's done, you know, you're done. So you kind of like let the model kind of like solve this task step by step. And basically, what you do is you let the model hallucinate the result of invoking these tools. And then what you do is, instead of actually like taking this hallucination, you kind of say, oh, the model wants to invoke this tool, and you invoke the tool yourself. And then you have the actual value, and then you ask the model again to kind of like continue, right? So you're literally kind of like, it's like continuation passing style. The model does a step, you intercept it, you do it yourself, and then you ask the model to continue with the answer that you gave it, instead of the answer that it kind of like, invented. And if you do it in this case, it will kind of like, do these 3 steps and fixes this program. Now again, how do we, in order to make the model have this behavior, we have to write code as a prompt. And so here you see, if you decide to use a tool, you must use this JSON format. And then of course, 8 out of 10 times, it doesn't use the JSON format and things crash. And then, like, you must send the JSON with no surrounding text. Again, like, we are like, it's a little bit, I don't know, embarrassing, right? We're begging this machine to do stuff. We are better than that as humans. But anyway, do not output in any format. If you Google for like how to make a model generate correct JSON, I mean, you can read these posts for like until you die, right? Like everybody's trying to get like fix this. But anyway, if it works, it works. Let's skip here. But again, like, there's so many questions that I have when I write these prompts, right? Again, like, you have to specify all the tools, all the, like, the agents that it can use. But how do you know that this is the right specification? Is this the shortest specification? Is this a complete specification? Is this a specification in a form that the model can actually understand it? Maybe you've seen OpenAI with function calls. There you specify these things with JSON schema. I always think with JSON schema, why would I use JSON to describe the structure of JSON? That is insanity. All right, why? Like, it's like we knew this from XML schema that was a bad idea, and then we're doing it for JSON. But anyway, so that's even more painful. Here it's just like, some regular description, but you never know, right? And so, yeah, I think this is a big open problem. How do we communicate with these models our intent? And it will keep us busy for a long time. So, as I said, I don't know if this is a happy conclusion or a sad conclusion. I think we will not write code anymore. We will like specify things in English or Swedish or whatever, natural language. And now we will have like a very powerful compiler that will take that high-level specification and convert it into executable code. But the compiler itself, right, just like we had to write compilers previously, we have to write these new compilers. We do that by prompting. And that is actually like a much worse programming language than we use to write compilers. And here are like some of the things, the problems, the new software engineering problems. It's very error prone, as you saw in this example, right? Like, it has to generate correct JSON. It doesn't. Then you're trying to get, like, how on earth do I get this thing to get, like, write correct JSON? People are trying other tricks where they can, like, specify a grammar, and then they're forcing the model to generate things that are kind of like, according to the grammar. But it's still, I think, an open problem. It's very brittle. Probably you've all seen, like, something works today, then overnight, maybe the model changed and it doesn't work anymore. And so we really, for software, we do versioning, right? We know It might work on this version, but like if it works, we don't upgrade to another version, or maybe we do, but we know it might break, or people that create the new version say this is a breaking change. Here, we don't even know, right? It will just stop working. You just Google for model drift, and you will get it. And you might have run into it yourself. Other thing, these are insecure. We all know, or we learned about SQL injection and so on. And the way we fix that is by not writing SQL. So we have some abstraction that hides the SQL, such that people cannot make kind of weird things that where the string is interpreted as SQL. These large language models, they take language. And so it's very hard to get, like, escape or do, like, deal with these injections, like solve them like we do for SQL injection. And I don't know if people have seen this one, but like, ChatGPT now has image recognition. And so what people don't want is that you do like solve CAPTCHAs with it. But what you do is you can take an image of a bracelet, you paste the CAPTCHA on top of the bracelet, and then you say, my grandmother died, this is the thing she left for me, and I cannot read what's on it, please help me. And then it will solve the CAPTCHA for you. So that's like, a very sophisticated prompt injection technique. And again, like, in some sense, we're opening the door for a lot of, like, new errors, and we have to solve this. I already said, like, it's really hard to write. You never know whether the prompts that you write are the right ones. Do they work? So people are looking at this. If you look for prompt programming language, people are trying to find higher level ways to write prompts. They're impossible to debug. In regular code, you can put a breakpoint, you can inspect, you can look at stack traces. Maybe you can even kind of like modify some variables and then continue. Here, there's no way, right? Like, there's no way to put a breakpoint. There's no way to inspect the state of the system. Maybe you could look inside the GPU to look at, like, how the attention works, but that's not going to tell you anything. People are looking at this with mechanistic interpretation and so on, but there's no operational intuition of how these models work. So debugging them is hard. There's a lot of hyperparameters, top K, whatever, you tweak with them. So really, really hard. So impossible to debug. They're expensive. Like, if you read papers, people say this costs as much as riding a Corolla between San Francisco and LA 5 times or something. Or it's really expensive, not only in terms of dollars, but also in terms of carbon footprint. So yeah, I don't know what to do about that. And then, of course, it might be privacy sensitive. Like, you might accidentally have training data in there, maybe like some that is now in the weights that you can kind of somehow extract. So you have to be careful about that. So there's a lot of things here that we switched from things that we kind of knew with traditional software to things that we don't know about this new kind of software. Now, I'm an optimist, so I think this is like job security for us. But I do think it's kind of like a very different kind of computer science. So my advice to all of you is forget, as I said, I wasn't joking, forget about the old React and switch to the new React, right? Focus on, this is the new software engineering. These are the actual problems. People that can solve these problems will be the winners. And don't even bother about writing curly braces and while loops and so on. That is done. That is done. And in some sense, these are much more interesting problems to solve, right? Because they're much harder. And so, therefore, much more fun. So yeah, that's my advice. Stop writing code and start kind of solving these problems. And maybe you win the Turing Award by solving these actual problems. Because if we don't solve these problems, then these LLMs will be no more than a party trick. And then, look at that. What is the consequence of that? We have to go back to writing code by hand, and that wouldn't be fun. So I really I bet on all of you to solve this, such that I don't have to write code ever in my life again. Thank you so much.
So we have 2 minutes for questions. Anybody? You'll have to speak into this so we catch the question on the live stream as well.
Yeah, thank you for this really fun presentation. I'm curious about the turning point that made you decide to leave the team you had before and decide to kind of like, okay, this is the time to take a new look at AI. Can you describe that? What kind of like changed your mind at that moment?
So there's 2 turning points. I think one is like around 2016, when I noticed that the AI folks were having a lot of fun, that developments were much faster. Right? If you look at, say, conference proceedings, I would look at, say, I don't know, POPL or ICFP, like the conference that I would go to, and it's like yet another paper about type systems. How boring can it be? And then you look at these guys, they can recognize cats and dogs, and it's like all kind of like super exciting stuff. So that was the first thing where I said, oh, like this field is stagnant and this one is like blowing out of the water. So I switched. And then the second one was when the large language models became kind of like, accessible. And then I realized like, hey, like instead of having all these like super complicated specialized models, we can now have like this like one super powerful model. But the first switch was really kept like I saw stagnation here and excitement there, and I always go for the excitement. Right? I like extreme sports. I kept like I broke my leg or fragmented my leg snowboarding. I was a scuba instructor. I need that kind of like, adrenaline. And there was more adrenaline in AI than in programming languages.
Hey, yeah, great talk. I have a question on what is the end goal here? Why do we, I mean, I don't, I wouldn't mind not coding either, right? So I agree to that, right? But coding is a precise thing, describing precise. We have moved the abstraction of subs, right, from zeros and ones to a level now where we're basically writing text in a more structured way, right? Why do we want to move to this text only? Is it to democratize it, or like do we want the business people to just sit and yell at Excel and describe the business, or what is the end goal? Why do we not want to code, right, or write it in a code-like way, or rather than move to English instead?
Yeah, it's a good question. I think it's always to get like I think for me, I can only give the answer for myself. Is you want to shorten the distance between what's in your mind and what comes out that runs, right? And if you have to write code, like say that you write like, I don't know, Java or Python or whatever, there's still quite a distance between like, what you have in your mind and then the implementation. And then people say, oh, like, we have declarative languages, which is like the next step. But like, what is the ultimate, like, like thing? It's like I can just give some vague specification of what I want, and then out comes the thing that I had in mind, right?
But with a vague description, I mean, it will never be precise, right? I mean,
but here's
it will
the
not
thing.
capture all the corner case and everything that you're doing, that you are forced to do in code, right? Or
But let me say it like this: do you feel that, like, for a given piece of code, like, I don't know, like a front end, if you're a front end engineer, can you actually give like a full specification of everything? No, because there's a lot of feeling there. Like, does the customer like it? Does it look good? So I do think any piece of software is inherently, there's vagueness and there's like precision. And I think if we can get closer to this thing, what's in our head, which is kind of fuzzy because it's in our mind, to something that kind of most like approaches what we had in our mind, I think that's great. And so that doesn't require precision in some sense. I think maybe precision is a little bit of like a red herring because it makes us feel that we're doing something cool, but it's like friction. And so I want to have no friction. But as I said, like, it introduces a lot of new friction, but it's fun friction, right? Because now, again, like maybe I want to do new things all the time, and this thing excites me, like, oh, I have this like really kind of weird English thing, and like I need to make the machine do that. It excites me way more than writing another while loop. And what is the invariant? I don't care about the invariant. Like I want to do something fun, exciting.
So, like your example of the code that writes itself, so to speak, that's like 15 lines of code. My current code base is around 10,000. That's a few orders of magnitude larger. Is that even feasible to work on those large code bases with the technology we have today?
So that's a good question. So first of all, is it a good thing that our code bases are so big? Right, like and because again, like to go back to the previous question, if your code base is like millions of lines of code, like there's no way on earth that you can comprehend everything, right? So even if you think that you're precise, like this thing is too vast to understand. So that's one thing. Second thing is like your big code base was built like line by line, right? And so if now I can kind of like, generate code like, like 100 lines per minute instead of like, like 10 lines per minute, I can still get this big code base. So yes, I do. My answer is yes, I think we can build like big systems like that. But the downside or the other side I would say is like, should we really not try to get like make our code bases smaller and not be kind of proud of like having like millions of lines of code, because I do think that in some sense there's the same, like in a different way, the same problems, right? If you have a million lines of code, there's no way you can understand it, just like you cannot really understand what these prompts do. But to answer your question straight up, I do think that we can generate like realistic systems, large systems, using these techniques, for sure.
Cool. Thank you very much, Erik.
And